Okay, students, my name is Theodorus Gazau. I'm your physics teacher. Today we'll see about thermodynamics. In this, before we start, let us see the key points or the important terms. The important terms, the first one is adiabatic. When we say adiabatic, the expansion or the compression of gas without a gain or loss of what? Heat energy. If the heat energy or change in Q is equivalent to 0, the process is named as adiabatic. The second one is Carnot Principle. According to Carnot, the engine operating between two reservoirs at constant temperature can have what? Greater efficiency than reversible engines operating between what? The same temperature. This is Carnot's principle. Further, we'll see on all reversible engine operating between the same temperature have the same efficiency. And the second one is entropy. Entropy means the disorder or the disturbance. The amount of disorder in a system is entropy. And the other thing is first law of thermodynamics. The heat lost by a system is equivalent to the heat gained by the system minus the work done by the system. This is conservation of energy. This conservation of energy is determined or explained by using first law of thermodynamics. The other thing is heat engine. When we say heat engine is a device which can change internal energy into what? Mechanical work. Heat energy to mechanical work. And the other thing is isochoric. Isochoric is the process in which it is thermodynamic process. This thermodynamic process of temperature of a gas remains what? Constant. Therefore, in isothermal, the temperature is always constant or similar or remains stationary. The other thing is pressure volume diagram, PV diagram. This PV diagram is drawn by using pressure versus volume, and indicates the work extracted by the system. And reversible processes. These reversible processes are a process in which both systems and its environment can be returned to what? Exactly the state they were before the process occurred. If this happens, we can say the process is reversible. The irreversible process is the inverse or the vice versa of this definition. The other thing is second law of thermodynamics. Second law of thermodynamics can be defined in so many different ways. Among these, the first one is heat flows naturally from a region of what? Higher temperature to lower temperature. This is second law of thermodynamics. All natural systems tend toward state of higher disorder. That means when the temperature increased, the disorder of the system also increased. And thermodynamics, when we say thermodynamics means that the study of heat transfer. Therefore, thermodynamics studies about the heat transfer. The other thing is equation and symbols, which we have seen in this topic. The internal energy mean that change in internal energy means, since it says change indicates final minus initial. Therefore, change in U is equal to U final minus U initial. This U is the internal energy of a system. And when we say change in Q, Q final minus Q initial. That means the heat energy final, that means after contact, and the heat energy before contact, the initial one. And work for any ideal gas or for any gas, work done is determined, pressure is constant, and work is created because of change in volume. Therefore, work is equivalent to P times change in V. Change in V indicate that, as I said before, V final minus V initial. And this efficiency, the efficiency of a system, is equivalent to efficiency sometimes symbolized by E is replaced by eta, a Greek letter eta. Both are similar. We can use one of the two. And efficiency, this one is equivalent to eta or E. Efficiency is determined the work extracted divided by the heat added to the system. Or we can also express in terms of temperature. TH means T, temperature of the hot reservoir. TC is the temperature of cooler one. That means the heat absorber divided by TH. Or if you divide these two, you can get this equation. And the definitions are given there. Let us see one by one. What is thermodynamics? First law of thermodynamics and the other parts. Thermodynamics is, as I said, the study of what? Heat flow and work done on or by the system. There are 4 laws of thermodynamics. Actually, we have seen the three laws. We will see the 3 laws. The 4 laws of thermodynamics of 2 appears on epiphysics. That means in this book by the name first and second. However, the concepts are involved in the other 2. Which one? The zeroth law and the third law are important to understand that thermodynamics, as well as what? The zeroth law of thermodynamics. That if 2 systems are in equilibrium, the zeroth law of thermodynamics state that if 2 systems are in equilibrium, that is, they have what? The same temperature, there is no net flow between them. This